Welcome to the Bearing and Drive Solutions Continuing Education and Training Program. Today we're going to demonstrate best practices on installing a QD bushing. A little history on the QD bushing. It was originally known as the Quick Detachable, and then it was shortened to QD. The bushing was actually invented back in the late 1800s by Worthington. Worthington saw a need to simplify a friction fit in the field and developed the QD style bushing. The bushing is a 100% friction fit. Now let's take a look at our components that we're going to utilize today. Starting with the QD bushing. Comes in a box. In the box you'll find something that's seldom used but needs to be used all the time. Instructions on how to install the friction fit bushing. Next, there's a packet that comes with 3 lightly oiled bolts, lock washers, and in this case, key stock. This comes with key stock because this is a shallow keyway that's in the bushing. Next, as we look at the QD bushing, we see that it has 6 holes, 3 of them tapped, 3 of them untapped. Also, we have a tapered cone surface, a set screw to snug up the key stock. Our next component that we're going to be utilizing to install today is a QD style sheave. Again, you'll notice it has 6 drill holes on it, 3 of them tapped, 3 of them untapped, and a tapered cone surface. And we're going to be mounting it today on this 7.5 horsepower motor that comes with a 1 5/8 shaft, a standard keyway. So let's look at the tools that we're going to utilize. And remember, this is a friction fit. Because it's a friction fit, the first step of every manufacturer's instructions is to clean all the working surfaces of the bushing, the bore, and the shaft. The tools that we're going to be using to install the shaft, bushing, and sheave, so we're going to be using a degreaser to clean all the tapered cone surfaces, the shaft and the bore, set of rags to wipe it down, a ratchet to tighten the bolts, an Allen wrench to tighten the set screw. I'm going to be using a torque wrench properly adjusted to the torque listed on the instructions, a 6-inch scale, calipers or vernier to measure the shafting and the bores, definitely a dead blow hammer, a block of wood, and most likely a screwdriver. Things that we will never use on a friction fit installation for a QD bushing would be grease of any sort, oil of any sort, or a torque gun. I've been asked many a times over the years, why not a torque gun? I see it used when they install your car tires. Well, we have 2 tapered cone surfaces, a tapered surface on the bushing, and a mating taper surface on the sheave. When you put these 2 together, they are not in the same plane. When you mount your car tires, you have a flat flush hub on your rim and also a flat flush area on the hub to your wheel. So by using a torque wrench or a torque gun, 2 flat surfaces, no problem. Tapered cone surfaces, big problem. If you ever were not able to dismount a QD bushing, you have a 99% chance it was not installed properly. So today, using our best practices, we're going to properly install a QD bushing into a sheave onto this 1 5/8 shaft. Next, what I suggest doing to save your time out in the field in your shop when you're putting it together is just confirm that the shaft is on size and the bushing is on size so that it makes it easy for installation. So on the 7.5 horsepower motor, we're to have a 1 5/8 shaft, and we have a 1.6245 shaft, which is exactly what it's supposed to be. Next critical piece is to check the shaft size of your bushing. And as you can see, it is slightly undersized. Now, it's good we checked this because we have a solution to an undersized bushing. You're probably wondering, like, how did the bushing get undersized? Well, the bushings are made out of cast iron, ductile iron, steel, stainless steel, sintered metal. All those machining operations cause a lot of stress in the bushing. So a lot of times, one of the final operations from the manufacturing side is the manufacturer traditionally anneals 180 degrees from where they're going to saw split the bushing. And this is to cut down on the bore size moving on the bushing. So I always look at it, you have a 66% chance on every bushing that it's going to slide right on the shaft, because the bushing could stay the same at 1 5/8. It could expand a little, which is no problem to go on the shaft, or in this particular case, the bushing actually collapsed a little bit. So to work around the collapsing, and before we do that, we're going to slide. When you look at your sheave instructions or your bushing instructions for a QD, the SH bushing that we're using, it says there's a standard mount and a reverse mount. Standard mount, all that means is the bolts go through the unthreaded hole in the sheave and thread into the flange of the bushing. A reverse mount is exactly the opposite. It actually goes through the untapped holes in the bushing into the threaded holes in the sheave. Now, traditionally, when you install a QD bushing, you want your greatest weight of your bushing and your sheave closest to the bearing surface of the motor. For ease of viewing today, we're going to do a reverse mount. So to do a reverse mount, first thing we do is, after we had cleaned with our solution and we let air dry the tapered cone surface, and it's important after you clean your areas, let it air dry. If you automatically start putting it together, steel is porous, cast iron's porous, what happens is your solvent that you use to clean actually acts as a lubricant and will make it impossible to get a press fit, a friction fit onto your shaft. So now this is all air dried, so we're going to slide the sheave onto the shaft. We're going to take our key stock, which is non-standard, because the keyway, as you can see, is a very shallow key. And again, the bushings come with non-standard keyways where you have shallow keys. We're going to place the key stock into the key slot on the shaft. Next, we're going to take our bushing, which we know is undersized, by checking the bore. Now, I've seen people already where they take a screwdriver and they're going to put it into the tapered cone surface. I strongly suggest not to do that, because as you can see, it's the thinnest part of the bushing and it can actually do damage to the bushing itself by cracking it. So I suggest taking it and putting it into the flange area on the bushing. And now I'm just going to take my dead blow hammer, because I have it, and that's one of the tools that we may need later on also. We tap it a little bit. Notice I didn't start here in left field and whack it. Now we're sliding it on to the shaft over the key stock. Now wherever we put the bushing, that's where it's going to stay. A lot of people think the bushing is drawn in to the mating part, but the bushing actually draws the mating part onto it. So the next thing we're going to do is we're going to take our Allen wrench and tighten down the set screw into the keyway. And by doing this, you just snug it up. It's only to hold the set screw in place. Now we're going to slide up and we're going to line up an unthreaded hole with a threaded hole on the sheave, and we're going to take our lightly oiled bolts and lock washers. They come pre-oiled, so don't add any additional oil to it and don't degrease them. So as you read the instructions, a critical part of installation, and this is where the vast majority of things go wrong, is it says alternately tighten the bolts. Alternately tightening the bolts means at the very beginning, what you need to do is catch the thread and catch the thread. Now that we caught the threads, you're wondering, well, why did you just catch the thread? Well, the threads are actually machined to within probably several 10,000ths accuracy of each other. So since we have two tapered cone surfaces, if we were to look at it on a down view, you would see that the sheave is on a very slight angle because it's two tapered cone surfaces. Now to alternately tighten it, we're just going to use a socket here because everything's pretty loose right now. We do one revolution, 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 one. And what's happening now is we are drawing the sheave cone surface uniformly onto the bushing. Now you're thinking, boy, this is taking a long time. But keep in mind, if you were to do a friction fit out in the field, number one, you'd need a hydraulic press or a torch to heat up the bore. Today they even use liquid nitrogen on the shaft. And I've seen friction fits out in the field that can take sometimes as little as 30 minutes or up to 8 to 10 hours. And of course, when you're doing a friction fit in the field, you only get one opportunity to get the part exactly where you want it. Now, one last quarter turn, quarter turn, quarter turn. Now it's snugged up. Next, when we look at the installation instructions to the bushing, it says that the SH bushing needs to be torqued to 108 inch-pounds. That's very important because that's going to supply enough friction fit for this application to have no problems. So now we're going to take our torque wrench, not our torque gun, no torque gun, torque wrench, and we're going to adjust it. This is in foot-pounds. 108 inch-pounds happens to be exactly 9 foot-pounds. 108 divided by 12. You have it, so we adjust the torque wrench to 108 inch-pounds, or in this case, 9 foot-pounds. We take our socket, and we're going to do the exact same thing. We're going to go quarter turn, or I should say half turn, half turn, half turn, and again, half turn, half turn, half turn, quarter turn, click, click, click. Now, if you noticed, all the bolts torqued off in less than one revolution of each other. This is telling me the bushing has now been drawn together very accurately. Now, in 1980 and before, the instruction said to run your machine for 24 to 48 hours, lock it back out, retorque the bolts, and you're good to go. Well, today manufacturing doesn't want to wait 24 to 48 hours to shut the machine down. So what we're going to do next is we're going to seat the bushing, because right now we're torqued up on the machine lines. It's a 125 finish. Okay, now I'm going to do a scale drawing. You're in for a treat, because you're thinking, well, what kind of scale is that? Well, this is my scale. So this is the tapered bore of the sheave, and this is the tapered cone surface of the bushing. We're going to take this area right here and blow it up hundreds of times underneath a magnifying glass. And what we're going to see is we're going to see a whole bunch of these lines. Because these are the machine lines on how the sheave was bored and the bushing was turned. Now, 125 finish means that the distance from this valley to the top of this peak cannot exceed 125 microns. So right now, the bushing is torqued up on the machine lines. And that's why originally run 24 to 48 hours, retorque. To speed things up today, we're going to seat the bushing and sheave together. Now, to seat the bushing, what we're going to use is we're going to use a block of wood and a dead blow hammer, or if you have a regular hammer, that's good, but always use a block of wood, because you'd never want to use a steel hammer onto a metal bushing. So right by each bolt hole, we're just going to come up and we're going to tap by each bolt. Now, what we've done is just by that little tapping, and pay attention, I didn't start way back here in left field and whack the bushing, and this works regardless of the size of the bushing. Of course, the bigger the bushing that you're installing, a little bit more effort needs to be put into the seating of the bushing. We're going to take our torque wrench again and see if we get any movement out of any of the bolts. Up. See, we got almost a quarter turn. Next one. Nope, no turn at all. And the last one, again, a quarter turn. Now it appears that your bushing is mounted properly. For the final inspection, what I suggest doing is we're going to take this 6-inch scale, because what should never happen, this split line should never be closed. If this split line closes, stop right there, something's wrong. there could be grease or oil on some of the components. Your shaft could be undersized because we're putting this on a new motor, but a lot of times when parts are replaced, we have a tendency to take some emery cloth and emery the shaft. So to check, we can see our scale slides right in there. Next easy check is we're going to take our caliper and we're going to measure it at 120 degrees, and there's only a 0.5 thousandths variance between the machine surface of the flange and the machine surface of the sheave. Now, as a quick recap, important things to do. Clean everything. A QD bushing is a friction fit. Next, catch each thread. One revolution, one revolution. This draws the part onto the bushing uniformly. Use your torque wrench. When the wrench torques off, it should torque off in under 1 revolution of each bolt. If it goes more than 1 revolution, stop right there because your bushing is locked on an angle and you'll probably not be able to dismount it 5 to 10 years when you go to change it out. Next, seat the bushing. Finally, check the split line, check the uniformity of the flange to the mating machine surface on the sheave. And now we're ready to run in the field with our installations good to go. If you have any comments or questions in the future, please feel free to contact your bearing and drive solutions people, and they will be glad to assist you either over the phone or in the field, or if you would like some in-house training, they'll be able to come out and help train your mechanics. Thank you and have a good day.